Okay everyone, welcome to part 4, the electronics section of the Terminator build series. This is going to be the electronic and wiring section. I'll try and make it as short as possible, but it's going to be tedious to explain everything, so we'll jump right into it here. Here's basically the basic stuff you're going to need. You're going to need some 14 gauge wire, which is this wire here. This is 14 gauge. You need some 12 gauge, or sorry, 16 gauge. And then this one here, the smaller one, this is 20 gauge. So you're going to need 14 gauge wire for the main connections to the power supply. The 16 gauge will be running all of the buck converters that do the voltage conversions. It'll run the LEDs, and then this 20 gauge will run the fans and the end stops. You'll need a soldering iron, at least 40 watts. Get a good brand. This is a cheap one, but I would recommend getting a good soldering iron because a cheap one will make your life miserable when it comes to soldering. This is a pair of good wire strippers, Klein wire strippers. This is just Kester safety solder, silver solder. There's no lead in it, so no lead poisoning. These are spade connectors that will fit 16 gauge wire and 14 gauge. So just make sure when you buy the spades that they are set up for 14 through 16 gauge. Otherwise you're going to go to insert the wiring and solder and it'll be too small. This connector here, go ahead and circle this one. This is what's called a DIN connector or a DIN plug. And there is another name, but I can't remember it at the moment. This is usually pretty common in RC cars and airplanes. They're very dependable and they come apart easily, so when you press them together they won't ever fall apart, but when you want to remove them you don't have to struggle to get the plug apart. So I would highly recommend these for the power connectors, for the LEDs and stuff like that that uses higher current. This here, this loop with the two plugs on it, that is a fan extension, a PC fan extension, and you're going to use these to make your own wiring harness to run all the fans. The other thing I would recommend if you use these is make sure that the harness itself has the female plug and the fans themselves have the male plug. That way you don't have exposed terminals that are hot. They have voltage to them. This is a smaller 2-pin. I can't remember exactly what it's called, but it's on the bill of materials. It's a 2-pin connector that goes on the Arduino boards, and it runs the fans and end stops and stuff like that. So these are going to be on the bottom as well, so if you need to solder one of these plugs onto something to fit the board, you have it. This is just basic electrical tape here. Can't draw. These are power pole connectors here. These are a little hard to get apart. They're very dependable. They're a little tricky to solder, and they're quite difficult to remove, so I would probably not recommend these. I would recommend the DIN plug over here. This is more expensive, but just easier to remove. And then these are bullet connectors, which I used because I was in a hurry modifying the printer as I went along. But these are also hard to get apart. A little dielectric grease on the terminal here might help, but I would recommend stay away from these unless you just want to rush and put this thing together. This is just heat grease right here. You're going to need that for the LEDs. And then this is heat shrink tubing. So this piece here and this piece here are just heat shrink tubing to put over the wiring after you solder it. Okay, so the first thing we're going to do is we're going to get into wiring the AC power harness. The one on the bill of materials is actually fully assembled, so there's really no soldering on the harness itself. This plug here, this is the main AC plug here. You can't see my writing real well because it's red, but this is your main AC plug, and this is your on-off switch here. This is the power on-off switch. This harness has to be mounted into this 3D printed block, but the harness itself is fully assembled. All you should have to do is solder the spade terminals to the actual, or sorry, not solder, but connect the spade terminals to the power supply. So go ahead and you should by this point have all of your 3D printed stuff done. Go ahead and put these in the block to keep them held together. And as a forward here, all this soldering is done with the printer unplugged. Never ever mess with these connections when the printer is plugged into the wall outlet. So make sure you're you're disconnected from the AC power when you do all of your wiring and soldering. This is going to be the DC power cable that powers the HDMI converter that runs the screen. So right here, this is the HDMI power in, which I believe is 12 volt, and then this is just a 5.5 millimeter, basically an extension, what they call an extension cable. It's made for power supplies and stuff like that, and you can just trim off the excess cord and put spade connectors and just connect this directly to the power supply. And that way, when you plug this plug into here, you've got a perfect 12 volts powering the HDMI converter. This is the actual power supply itself. These 3 wires here, just a side note, obviously this wiring will be different if your power supply is different, so if you have this exact same power supply, the wiring should be similar to this. If not, you need to read these diagrams up here. If you don't know how to read these, look it up. But basically, this is the 2 hot wires for the AC here, and I think the yellow one here is the ground. I believe this symbol is the ground symbol. I can't remember, so be careful when you hook this up. If you hook this up wrong, you're going to short something out, and there could be a lot of sparks because you're using 120 AC. On this power supply, this line right here, this is where the DC side is, so this is your input over here, your AC input, and over here you have DC right up here so we can see it better. And the way this works is you see this negative and this positive here. They split the negative and positive into sets of 3. So you have 1, 2, 3 are all positive, and then 4, 5, 6, this set here is all negative. So that power cable I just showed you guys right here, this power cable, when it runs up to the power supply, is connected right here. So the positive would be this black wire here coming in, and then the negative would be this one here that comes right along here. And then these other cables, some of these are stacked because I had more than 3 connectors. So some of these have 2 spades going into the same clamp. But that shouldn't be an issue as long as you solder them correctly. Let me check here. Next, you're going to want to solder up your fan plug harness, and you're also going to want to mount the input fan. So this is your input fan on the left side of the printer. It's going to mount like this. This bolt just goes up into the railing and it has a little captive nut. Note the tape right here, this clear tape right here. It's coming around the edge. That's holding this filter media that you see right here in front. That filter media just collects dust, so you put the clear tape on the very edges to keep it in place, and then the case out here, this case part, is not attached to the fan, so the fan itself is hanging here on the frame. So go ahead and attach this like so, and then these wires here are the power wires from the fan, obviously. Those are going to come down. This is a side view of the fan mounted. This is before I put the filter media on there, so you would put, there's a little grill that you 3D print, and it has bars that go across horizontally like this, or I guess you could flip it vertical if you wanted, and it just keeps the filter media from getting pulled into the blades. So you put that little grill on first, then you tape on the filter media, which is just a register filter for a home. You just trim a little piece off, and then you're good to go. Okay, so this is what's called a trim pot. It's basically an adjustable resistor. These wires here coming in from the top are the fan wires we just looked at. These wires here. And basically I'm just running, I believe the yellow one here, I'm not sure why this yellow one is here because you only need 2 wires on most of these fans, but the blue wire is, this blue wire here is basically the same as the black wire over here. So you just split the black wire between, I believe, terminal 1 and 2. and you can also use 2 and 3. The direction is just reversed. And when you spin this little dial here with a screwdriver, it basically sets the resistance to the flow of electricity, which allows you to slow down the fans. And you need this because when you get done assembling the case in the next section of the build, you're going to need to set the inflow of air to be basically equal to the outflow. If it's not, then you'll have air leaking out of the case. So you need these trim pots on your input fans to control how much air is coming in. So I don't think this is on the bomb, but this is I believe it's a 500 ohm trim pot. So you're going to need some of these. Okay, so the next thing is connecting the end stops correctly. I'm going to go through a couple of pictures here and try and show you guys how they're mounted. This is obviously the Z-axis going up and down on the printer, but this is the end stop itself here, this tab, and this would be the top of the printer looking down. So this arrow is pointing down. So this green wire, note that this green wire is on the top and the red wire is below it. That's going to be from the top of this plug. If this is looking at the side of the circuit board, right, the top side of the circuit board, you're going to have the green wire in spot 1 and the red in spot 2, and then 3 and 4, I think it's a 4-pin connector, 3 and 4 are just blank. So you will have to move these wires. They're not in this position when you get the end stops. So you're going to need to use a little micro screwdriver to release these wires. You push down a tab, release the wire, and you put it into these other connections. So let's see real quick here. This is the top one. So same scenario. You got to move the wires with a little screwdriver, but this one is upside down because when the platform comes up this direction, you want it to hit the end stop and stop. And then same thing. This would be the top. This would be the top of the end stop here, even though it's upside down, and the green wire would be on top. The red is number 2. So, and you're also going to want to mount the Z-axis, obviously, by this point, because you're going to need to connect the motor to the board to test it. So go ahead and mount the motor if you haven't already done so. You do need to use lock washers in here. This is just a regular, I believe this is a 1/4-20 washer for a 1/4-inch bolt, and then I have I can't remember if this is a 1/4-inch or a 5mm, but anyway, this is a regular washer. This washer here, just under the head, this is a lock washer, and you need these because these motors generate harmonic vibration, which basically will loosen these screws over time. And that means that this motor will start sliding down the frame, and that will throw off everything because the distance between your platform and the bottom of the vat will change. So make sure and use lock nuts here. This little thing barely clears. The set screws barely clear these, but it does work. So go ahead and assemble all of this and get it put in there. Here's another picture of the end stops here when I had the case off the printer, so you can see there's no red case here in the background. It's just the frame and the electronics, which is basically what you guys will be working with if you build it in the order that I made the series. This is the top one. A little better picture because it's got more light. This is with the arm attached to the Z-axis that we went over in the previous one, so you can see the 4 bolts here that are holding it on. Here's the back side of the bottom end stop. So we didn't really get to go over this in the other videos because you couldn't see them, but basically you just 3D print this little bracket, mount the end stop to it, connect the wires up to it, and then it just bolts directly into the back of this channel. So you just put a little captive nut in between. There's a tab here and one on the bottom. You put a captive nut, slide it down this rail, and clamp it in the position you want. You can move it any time to any position you want. So pretty simple. This is the top one. This is the joiner brace that holds the 2 Z-axis together. And next here we're going to go on to, I'm going to skip ahead here for a second and show you guys the resistor. This is another thing you want to solder, is the temperature override resistor. The way Arduino works is that if the power gets disconnected from the hotbed, it will not allow you, or from the nozzle as well, it won't allow you to run anything, because that would constitute basically a fire hazard, because you have high voltage, or not necessarily high voltage, but high amperage current that has a short somewhere. So when there's no resistance to that circuit, the heater circuit, the Arduino board prevents you from running any G-code. So you need to put an override on that circuit to make the Arduino think that you have an actual heating element connected, because remember, these Arduino boards are not really designed for SLA printers. They're designed more for FDM printers, which have hotbeds and hot ends, and they have current running through them, obviously, to keep them hot. So all you need is this little resistor here, and I cannot remember. You can look up the color of the stripes. I don't remember how many ohms this resistor is. I think it's a 1K resistor. If you just Google it, you could find pretty easy a temperature override resistor, how many K it is. I think it's a 1K resistor. But anyway, this is the 1K resistor soldered up. Make sure that this lead and this lead don't touch each other. So I just kind of put some tape over here so this couldn't contact the frame of the printer and short out to anything else electrical, just as a safeguard. But you also would probably want to put a better option would be to put heat shrink tubing starting right here that runs all the way down each wire like this separately, and that way the wires can't touch themselves, and also they wouldn't be able to contact the frame and short out. So that resistor is going to connect right here to the GT2560, which is the main control board, the Arduino board. This is the plug right here where it connects. So it's going to be, if you're looking down at the board, this is the main USB connections over here. These are the USB connections. It's going to be over here on the bottom, the third plug over. So just make sure and connect it there, and that way you can run G-code. If you don't have that plugged in, it's not going to let you run any commands from this driver to the motor. It's going to do nothing. So now that we went over that, let's go back real quick, and then you're going to mount the GT2560, which is the control board. You're going to solder up that resistor first, and then after you mount the board, you can connect it, obviously. So when you mount the GT2560, we're looking down here on the printer. This is the right side over here, this direction. So there's a screw here, there's a screw here, and then there are two more screws over here. There's one right here at the front corner, and one right here on the right corner. Just be careful, you can't really see it because it's behind this plug here, but there's little tiny diodes or resistor circuits that are micro diodes or something mounted on the boards, and they're over here next to these screws. So be careful when you put these screws in to not accidentally crush one of them, because if you crush one, you're going to ruin the board. So make sure and wiggle the board around so that you don't smash them. I would highly recommend adding this heatsink right here. I added this heatsink with a little bit of thermal tape to make sure that the actual microprocessor doesn't overheat, because this thing gets pretty warm when you're running it for hours on end. So get some little heat sinks like this. I have another one over here. Just grab them at your nearest electronics store. You're going to connect this would be the USB port to connect USB. This would be your main power port here. So I believe it's 12 or 24 volts DC. So that harness comes with the board. It comes with the GT2560 if I remember right. And that will have spade connectors so you can connect it up to the power supply. So after you connect it to the power supply, you can just click it on here and you have your 12 volt power ready to go. You obviously need to put the driver in here, the motor driver. I think it's a 4988, A4988 driver. It comes with 4 of them, this particular board. And you don't really need them for this printer, but I just bought the board because I knew it was interchangeable with my other printers, so if they ever die I can swap parts. And these would all be driver slots for stepper motors, but the only one we're going to use is the very center one, which is the Z-axis motor. So you're going to put that one together, put this little heatsink on there with some heatsink tape, or sorry, some thermal tape. And this will be your driver that runs the Z-axis up and down. Oh, this is the connection here for the stepper motor, so you're going to connect the stepper motor right here. I don't remember changing the wiring for the stepper motors. I think I left them as they were, but just double check the colors and make sure that they're in the same order here on the plug. But you just plug the stepper motor in here. This right here is something else. I'll explain that later. So that plug and this plug, you can't see it because it's under the wiring, but there's another plug right here. Those two plugs are connected to the end stops. So when you're looking down at the board, you're going to put it in number 1, 2, 3, 4, 5. So 5 and 6 are going to be your Z-axis end stop limit switch connections for this driver right here. I don't remember which one's the top or the bottom, but you can just swap them if they're backwards. So this is with the main 12-volt power connected right here. Like I was saying earlier, you just plug it in this direction and you're good to go. Next, you're going to connect the HDMI board, which you kind of saw the corner of it earlier, but there's a screw right here, right next to the HDMI, and there's one in the corner back here, and one in this corner. And once again, these have little micro diodes right next to them, so be careful when you mount it. It is very important that you connect this ribbon cable in the back correctly. If you connect this wrong, you will fry your LCD and you'll have to order another one. So make sure it looks something like this. You need to have these 3 wires here, these black and white wires on the left side when you're looking down from the top. You're going to have these blue and white ones kind of in the middle, and then another one over here. If you flip this around backwards and connect it so that this blank area right here of the plug is over here, like this, it will not work. So you will destroy the LCD. And the only other connection that you really make on this board that's semi-permanent would be this connection right here. This plug right here. This wire goes to the backlight control keypad. So there's a little keypad that you use to control how bright the screen is or what the color balance is. So it actually has an adjustment, a hardware adjustment for that, which is something you need for this printer. It's very important. And I also put a heatsink right here to cool down this component. It was some kind of a microprocessor that got really hot, so I put one here to cool down the main processor chip, and another one here on this little accessory. Keep them cool. Now that you've got the main stuff mounted over there, we're going to go to the other side of the printer. This is the left side of the printer over here. This direction, that's the left side of the printer. And this is, you saw this earlier actually, it was underneath the input fan. So this is your main buck converter board. This particular one that I have on the bill of materials is a buck boost board, meaning that you can pump the voltage up or down in comparison to the input voltage. So if we were inputting 12, we could output 5, or we could output 30. So 5 would be a buck conversion or down conversion, and boost would be the 30, which would be up. A lot of boards only do one or the other, so it's kind of nice. You can send the voltage either direction. But on this one, I just basically use 2 screws. I use one here, and the one in the opposite corner you can't see over here somewhere. I didn't even use this screw here and this one because you don't really need them. These parts are just sitting in here basically, so the main bolts here just mount this to the frame. Just captive nuts. These nuts should already be inserted from the previous part into the frame. So here's a nut here that you can see. It should already be in the frame for you. And I'm going to show you the wiring now, how it connects to the voltage regulator. This little ribbon cable here, this white one, this goes up here to the control. So this little panel here that you're going to mount in the acrylic case when you get to the next section. When you look at the other side of this, it has a dial and a control, and you can set, it has a little LCD screen, you can set the voltage and the amperage so that when this unit turns on, you have a constant current flowing out and a constant voltage, which is pretty important for LEDs. You got to monitor their current. So go on to the wiring here. This is another view of the back here. You can see the input fan right here. This is the main harness that comes in from the power supply for all of the AC, or sorry, all of the DC 12 volt power. Directly, this wire here that comes up to this plug, this comes directly off of the power supply. This is the 14 gauge, so it can carry plenty of current for the fans and the LEDs that provide the backlighting, because we're drawing around 150 watts or 130, 140 watts at least through here, so we want to make sure that we have low resistance. So this is 14 gauge right here. And then after the plug here, I believe I used 16 gauge. So starting here, this is 16 going up this direction, and 16 coming off of this way. And this left side of the fork is basically the fan harness. So I had to manually solder all of this. We'll go into that here in a second, but this is all of the fans. So all the fans mount to this side of the harness, the left fork, and this right fork provides the 12 volt power to our buck boost converter over here that we were talking about a second ago. So let's skip to one more. Here's the rest of the fan harness. You can see all the plugs here where you can unplug and plug in the fans. And the reason we use this main plug here is just so we can disconnect the whole thing, get it out of the printer without taking it off of the power supply, because it's pretty hard to get to the power supply. It's in the back. Make sure we got the right image here. Okay, so the way this buck converter works, or buck boost converter, is it's basically a power supply, a miniature power supply. This is the input terminals here. So I don't remember which of these are positive and negative. Apparently, at least one negative is over here on the corner, and I know for sure this one's a positive because this is the red wire. I don't remember what the middle ones are, but they're marked somewhere on the board. But basically, this is 12 volts coming in here, right? You got your positive and your negative going in, and these just clamp in place. You do want to solder the end of the wires when you do that so that they can't fall out. So put a little solder into the end of the wires so that they don't just collapse. And then this terminal block over here, that's the output voltage for the whole thing. So this voltage coming out, if I remember right, is 32 volts, which is what the LEDs need to run. So we've got 12 volts going in and 32 volts coming out. This wire right here on the right is the positive, and this wire on the left is the negative. And what we did is we ran the positive through a solid state relay. So this positive wire comes up here, comes around, goes into here, and then inside here there's basically a bridge or a gap, and when we turn that bridge on, the current keeps flowing this direction, and it goes back out and becomes the positive that goes to our LEDs. So our main LEDs that provide all the backlight for the printing are powered on this cable. These are the main power wires, 32 volts going to our LEDs. So the positive circuit, this is an upstream circuit because it's an upstream relay because it's before the LEDs. I haven't had any issues with it, so I decided to leave it there. But basically this solid state relay allows you to turn the LEDs on and off without turning this whole power supply on and off over here. It would not be good to turn this on and off all the time because it has a lot of components that need to stay charged in order to work correctly. So we need to be able to basically take the output current and switch it on and off, but we don't want a manual switch. We want something that can be controlled by software. So we hooked up the solid state relay, and the solid state relay can take hundreds of thousands of cycles, which is important because you could do a print that has, let's say, 4 hours of print time, and you could have easily 800 layers. So you got to figure this thing is switching on and off for every layer to minimize heat, number one, and to minimize power usage, number two. So you need something that can take a lot of cycles and not break down. So the solid state's ideal for that. So now that you kind of see how this is connected up, all we did is basically, like I said, put a relay into the positive part of the circuit. These bullet plugs here, I would not recommend these I would recommend go ahead and use the DIN connectors for these. They're a little more expensive, but they're easier to use. These are so that you can unplug the lights and take them out of the printer as a module and not have to take the entire printer apart. So these make it easy to disconnect each LED bank and pull it out and service it or whatever you need to do. So go on here to the next image, get my writing out of the way here. So here in the background you see this right here is the relay. This is the same harness we were just looking at. Just basic positive and negative connection here. This is number 1. And then this one over here is number 2. So these wires coming up here are number 2 and these wires are number 1. And it's basically just bank 1 and bank 2 of the LEDs because they're split into sets. So I have a set of 2 LEDs in the front and a set of 2 in the back. And each set has a set of plugs here.